So now I would like to introduce Yanrui Ma. Yanrui is part of our development team, as you heard from Flavio, and he'll be speaking about dynamic ESDL. So Yanrui, over to you.
Thank you very much, Jessica and Edward. That was a great talk. And today I'm going to talk about the user-facing part of HPCC, which is the web services. And more specifically, I'm going to talk about dynamic ESDL, and especially the changes in 7.0. So that's a quick poll. Did you attend Rodrigo's Tech Talk, creating front-facing web services to deliver your HPCC system's query data, which happened a year ago? And yeah, as I mentioned, Rodrigo gave a very nice talk a year ago on ESDL and web services. And this talk is the continuation or second part of that talk. So let's just quickly review some of the basic concepts. What is ESDL? It is Enterprise Service Description Language, which defines web service interfaces using straightforward constructs. On the right-hand side, you can see an example. And it creates contract between web service and other components, such as ECL, published query on Roxy. And it has features like a powerful version control. So before we talk about dynamic ESDL, let's quickly review the current or legacy way of developing web service with static ESDL. It has this, you have to go through these steps to develop a web service. You define the ESDL and compile it. You create a new C++ project, which includes newly generated code from ESDL. Then you implement your business logic in C++ with a C++ project. And then step 4, you create this config manager component for this new ESP service. You define the configuration layout and transform XSLT. Then you release a new build, and then you deploy ESP with the web service. And it sometimes requires deploying the whole HPCC systems platform. The major drawback, in my opinion, is any further change to the web service requires updating ESP and HPCC, and also requires the build, release, deployment. Such changes like anytime you change the ESDL, all the C++ project, or they all require build, release, deploy. So why dynamic ESDL? Apparently, as we just talked, is because of the problems with the legacy web service development lifecycle. Time to market is too long, and it's tightly coupled with HPC systems platform build process, and deployment of interface changes and updates require ESP downtime. And dynamic ESDL solves those problems. So in summary, dynamic ESDL is the new HPCC ESP web services development mechanism. It uses an interface first or even an interface only development approach for most data query web services. The ESDL schema is all the code that developer needs to write. And because the ESDL engine handles most of the major web service processing work behind the scenes. So we also provide multiple GUI and command line tools to help to easily create and manage the services. And the dynamic ESDL in 6, before we talk about the changes in 7.0, here is the steps for creating a dynamic ESDL service in 6.4. as you can see, the first step, you need to define a static ESDL service and the binding with config manager. And then you define the web service interface with ESDL language. Then you publish the interface. You publish the interface. My screen just flashed for no reason. Then you make the interface available by publishing the interface. Step 4, you bind the interface to your web service declared early in step 1. And number 5, you configure your web service, you link it to the backend query. So entire process can be done pretty quickly. Most importantly, the interface updates and the configuration changes are all dynamic. You don't have to change any C++ project or deploy, release, all that kind of stuff. But there's a but here is the step 1 here is adding a new service still requires defining a static ESDL service and binding, and it requires restarting ESP. It's not, that bad. It's just anytime you add a new service, you do it in one time. But that creates a limitation that only one service can be bound to one port. So let's see how 7.0 solved this problem. This is, it's even simpler than 6.4. So step 1, you first define your web service interface with ESDL, then you publish it. You bind the interface to any available port on ESP, and then you configure to the backend Roxy. So the entire process is dynamic, and it can be done even faster. So the interface updates and the configuration changes are dynamic, of course, and plus adding new services is also dynamic. And as a result, you can bind multiple services on one port. So with that, how are the new functions implemented in ESP? I just quickly go through this. Dynamic ESDL engine is now integral part of ESP. And we have this ESDL monitor that is instantiated when ESP starts up, which listens for commands and carry out the command. And the ESDL bindings are all dynamically instantiated. The ESDL services and bindings are generated on the fly, are bound or unbound from the port on the fly, on demand. And you can bind multiple services on the same port. And we also provide the hybrid mode to help transitioning from static to dynamic services. And this diagram just illustrates the major components of this mechanism. So you can see the red dots are the ports that the ESP listens, all the services reside on. And then the dynamic ESDL services, one, two, or more services can share the same port. And on the left-hand side, the developer or administrator can use ECL Watch, ECL IDE, or ESDL command line tools to manage the services. All right. With that, I'll just do a quick demo with the ESDL command line just to show how easy it can be to create a new service. So let me share my screen. I need to click through a few steps. Okay, share. You saw the ESDL definition that I displayed in the first couple of slides. Step 1, you define this ESDL definition. which contains the service definition, and the service may contain one or more of, it can be dozens of methods, and each method takes a request and a response. And over here in this service, the request is a list of names, so is the response, which each name contains the first and last name. And what the service does is it sorts the list of names and sends back to the user. So first is ESDL. We publish the ESDL definition. We publish it, and that's it. You can see it successfully published the lowercase service name point 1, which is the sequence number, and combined to be the name of the new published definition. And with that, you can bind to any port on ESP. Before that, let's define. I predefined a configuration file, which is for this port. This query type for this method. The query type is Roxy, and this is the URL, and the name of the query on Roxy is name sort. All right, that's very simple configuration. So with that, someone give me a port to bind to. Okay, let's ask the computer for a port. Random. Okay, 21661. Okay, let's first check if this port is being used or not. Grab 21661. You see it's not being used by anything. So it's a good, we just use this port. So ESDL bind service. Before that, let me show you the ESDL command line options. It has 12 of also the command subcommands, and today we just saw the published one, and next we're going to use the bind service. Okay, so ESDL bind service. I bind to my local ESP and on port 21661. And what I'm going to use is this name sort service.1, this definition we just published. And I'm going to bind for this service. And the config for the methods is the binding.xml. See, successfully configured service, name sort service associated with ESDL definition, that one, and then on ESP, my ESP, and port, the port we picked, or the computer picked. So now let's look at if the port is being used. Yep, it is, ESP is listening on this port now, and we can browse to it, make sure the service is up and running. 21661, yeah. There you go. And the service is here, so we can add another items. And see, it's sorted the names by last name, and you get a service. So it may feel like a little anticlimactic because it's, that simple steps, which if you have that feeling, that means we did the right thing. we wanted to make it really simple, really easy to use. So with that, also another subcommand of the ESDL command line is the ECL, which can generate the ESDL, the UCL record structures from the ESDL file. So let's quickly try that. ESDL name sort. Put the result in the current directory. So we can see this file is gets generated just now, and it contains the record structures. And then the UCL developer can import this file to develop the business logic, which is contained in this file. You import this generated module. Then this file is this query just simply sort the names by either first or last and output to the response. Okay, with that pretty much is all the demo I'm going to do. And next, let's go back to the slides. I have to click through all these screenshots. So let's talk about a little bit about the UCL watch. The UCL watch changes in SAML. Bindings are now organized by ESP instance and the ports to reflect the new port-centric model. And we added some auditing information such as published by, created time, last edited by, and last edited time. And the binding operations are all using the globally unique binding ID in this format, ESP name dot port number dot service name. And definition of binding operations are better streamlined, easier to use, and also there are some UI improvements. This is what the UI looks like. You can see it's organized by instance and ports. And each port, there are multiple, one or more bindings, which corresponds to a service. There are also other dynamic ESDL changes in SAML. One of the significant ones is service scripting. It is part of the method config, and currently it transforms requests before they're sent to the backend. And there are also performance enhancements with ESDL cache and support for pure proxy methods and support for multiple services per binding. And this is an example of the service scripting. You can see the transform type is custom request transform. What it does is sets a field specified by the XPath to a certain value, and you can control when to set it, under what condition to set it with the conditional statements. And future changes in 7.2 or 8.0, one is we're going to have more powerful service scripting, not just for inputs, for requests, but also for outputs. And for inputs, it'll do much more than we currently do. We plan to be able to gather information from different sources, such as databases, Roxy, or other services. And for outputs, we can apply transforms to responses, logging, etc. And also, we're going to support more languages for plugins. Plugins are packages or DLLs that ESDL, dynamic ESDL can load to process requests. So with those microservices, you can develop services other than Roxy for services for Roxy queries. So currently Java is supported, and C++ is planned for 7.2. With that, pretty much finishes my talk. And another quick poll. What do you think is the most important quality of a web services platform? And I think with that, I'll turn over to Jessica.
All right, Yanrui, thank you so much. And we have a ton of questions from the audience for you. So while you take a peek at that, I'm going to go back to your first poll question. So the first question that you had was, did you attend Rodrigo Pastrana's Tech Talk, creating front-facing web services to deliver your HPCC systems query data a year ago? And we have the most awesome community. You guys, 85% of you say that voted said that you were there. So that's pretty significant. And I think also, Yanrui, this is an indication that your topic is just so important. All right, so let's get started with the questions. Yanrui, are you ready for us?
Sure, yeah.
All right. So our first question here is, how does the WS performance compare to the legacy ESP?
That's a very good question. They have been a lot of work put into comparing the performance of dynamic ESDL and the legacy ESP. And at this point, we are on par with legacy ESP.
Great, fantastic. All right, here is a second question for you, Yanrui. Besides interfacing with queries, what are other services that people are using dynamic ESDL for? Is it used in any product development?
Yes, for the product development, yes, it's already being used for some internal products, production environments, and there's a plan to that's actually active development for external customer-facing products. Also, besides interfacing with queries, with the capability of the plugins like Java and the C++ plugins, developers can use it to develop any kind of service that they have the need for.
Jessica, I think we lost you again.
No, yeah, okay. I think there are more questions. Let me take a look.
Yeah, take a peek, Yanrui, and while you prioritize those, I'm going to go ahead and look at the votes from the audience for your second poll. So the question you had then was, what do you think is the most important quality of a web services platform? So the clear winner is 50% with runtime performance and efficiency. We've got a runner-up, 25%, which is being easy to use, develop, and operate. And then 12%, we have a tie, completeness of features and functions, and conforming to open standards. All right, Yanrui, you ready to tackle a few more questions?
Absolutely.
All right, here's the next one. Can I write my entire web services logic in Java? Are there any Java version restrictions?
Yes. The answer is yes. The entire with the capability of the Java plugin, you can write your entire service in Java. Well, yeah, you still need of course, the ESP and the HPCC running, but the ESP will load the Java web service. So all the business logic, all the application-specific logic can be developed in Java. And are there any Java version restrictions? I think 8.0 and above would be good.
All right, great. All right, Yanrui, our next question is, where is the text-based ESDL definition language documented?
There's a documentation specifically for the ESDL definition language. It's listed on the HPCC systems website under the documentation part. Mm-hmm.
And whoever answered that question, if you still can't find it on the website, you can send a message. There's, certainly there's some contact emails on there, and that'll come to either myself or Trish, and we'll make sure that we point you to the right direction where you can get those. You can also send it to the Tech Talks email that we've got on here. All right. Yanrui, I think we're about out at time here, so I'm going to thank you for this awesome presentation. This is fantastic detail that you were able to provide, and your live demo, I think, was extremely helpful.
Thank you, Jessica.